Hello, college algebra. Okay, the second half of this lesson is going to be how to solve some other types of equations. All right, and this equation right here is going to be a, well, what do we call this? A radical sign. So we have a square root over here, and so sometimes they'll mess this up and they'll try to get you to do something. They'll add 2 over here, something like this, and they'll say to solve it. But you want to get this radical sign by itself. Okay, so we want to subtract so that we have, if we can, a square root equaling a number. So really what this means is I have this raised to the 1/2 power, so I can square both sides. Now remember, if 2 things are equal and I square them both, they'll still be equal. Okay, so what we're going to do is square both sides. Now we might create more solutions, so you got to check answers, but we can do this and they'll still be equal. So I square this and I'll get 9x squared, and then minus 6x is negative 12x plus 4 equals, and now when I have that square root squared, I just will get 9 minus 8x. So now I have a polynomial. Well, back to this. Let's get it all on one side. We subtract 9 from both sides. We add 8x's to both sides. So we'll have 9x squared minus 4x minus 5 equals 0. So now it's all equal to 0. So if I can factor this, we can get a nice solution here. So let's go ahead and, let's see. So this 9x squared, either it can be from 3x and 3x, or 9x and 1x. And that's the confusing part. We don't know which one it is. But luckily this 5 here is either positive 5 and negative 1, or let's see, we can put a 1 and a 5 here, and we can switch that to positive negative. Or we can do the same thing down here with the 5 and the 1 and the 1 and the 5. Okay? So we have these 4 that we need to check, and we can take a look at it. Or you could do the quadratic, or you could do complete the square. I mean, there's other ways to do this. If it's factorable, great. Maybe that's a lot to check. Guess I didn't even think about this, and maybe we just want to do the quadratic. X will equal the opposite of 4, so that's before, plus or minus the square root of 16 minus, well, plus a negative 4 times a, which is 9, times c, which is negative 5, over 2 times 9. Okay, so x equals 4 plus or minus the square root of 16 plus, let's see here, what do I want to do? 5 times 4 is 20, 20 times 9 is 180, plus 180 all over 18. X equals 4 plus or minus the square root of 196 over 18. Okay, and so we need to take the square root of 196, which is, oh man, is that 16? Let's see. So that's 160, and that's 6 carry the 3. It's getting late. No, that's 256. 13. So you guys have been knowing this answer for a while. X equals 4 plus or minus 13 over 18. So 4 plus 13, x will equal 17 over 18. 4 minus 13 is negative 9, negative 1/2. Okay. Now, those are our possible answers. We need to go back here and check to see if that'll work. Negative 1/2 gives me, let's see, that'll be a positive 8. 9 plus 8 is 17, so square root of 17. And then we go negative 1/2 here, so that's negative 3/2, and we will subtract 2. Boy, that doesn't seem like it's working. But 3 times negative 1/2 minus 2, negative 3/2 minus 2. So that's minus 7/2. Okay, 9 minus 8 times a negative 1/2. Well, that's going to give me a positive 4. 9 plus 4 is 13. So the square root of 13, did we make an error here somewhere? Let's go back to this. This was supposed to be that easy. We must have made a mistake in there somewhere. Neither of those were going to work. So this should be 9x plus 5 equals 0, or x minus 1 equals 0. 9x equals negative 5, x equals negative 5/9, or x equals 1. Let's see, that's negative 5, that's negative 9, and a positive 5. Yes, yes. Okay, now we go back in and we go 3 minus 2 is 1, and 9 minus 8 is 1, so we're good. And negative 5/9, we get negative 15 over 9, so that's going to be divided by 3 is to be 5/3. And then we're going to subtract 6/3, so that's negative 11/3. And then over here, negative 5/9 gives me 9 minus 8 times negative 5/9. Now that's going to be addition. That's going to be 40/9. So 9 plus 40 over 9. So 81 plus that is 121 over 9. So that's 11/3. Yeah, they both do work. Okay. Whew. There. That's what happens when something goes wrong, but you know that it should work. So, those both work, and, oops, what am I boxing there for? How about negative 5/9 and 1? Whoa! Okay. Let's try to recover from that. And let's do a better equation here. The other two examples are both what we call quadratic-like equations. Now, when I say quadratic-like, that means they're to the second degree. But, okay, yeah, x to the fourth minus 3x squared minus 2 equals 0. Now, these are quadratic-like because this isn't a quadratic. This is a quartic. It's raised to the fourth power. But if I say that w is the same thing as x squared, then w squared will be x to the fourth. See, w is this x squared. I notice that this exponent here is 2, that one's 4, this is double that one. Whenever the exponent at the end is double what this one in the middle is, so the degree is double that one, I can use this and think of this as w squared minus 3w's minus 2 equaling 0. Well, if that were the case, hey, we can go ahead and see if we can... Did I get the right one here this time? Yep. We can go ahead and see if we can, figure this out. I'm thinking w will equal, this time it doesn't look like I can factor, because a negative 2, they have to be positive negative, and I'm not going to get that. So w equals the opposite of that, so the opposite of negative 3, plus or minus the square root of 9, minus 4, times a, which is 1, times c, which is negative 2, all divided by 2. Okay, so w is 3 plus or minus the square root of 9 plus 8 over 2. W is 3/2 plus or minus the square root of 17/2. Whew! Yes, but wait a second. We wanted to solve for x, not w. So w was x squared, so this means that x squared is 3/2 plus or minus the square root of 17 over 2. So that means x is plus or minus the square root of 3/2 plus or minus the square root of 17 over 2. So how many answers do we have here? We have 4 answers. You might want to write this is right there, x equals at or x equals plus or minus the square root of 3/2 minus the square root of 17 over 2. Notice my 7s have the slash in them and my 2s do not, even though they kind of look like z's. Okay. So we had a problem that wasn't really solvable kind of by what we've done, but we made it into a problem that we've done before, and we solved. Okay? We're going to do that again. Let's do that again. And this time, let's hide it a little bit better. And we'll call this x to the 1/5 minus x to the 1/10. Let's see if I have this right here. Yeah, equals 2. Okay, so we're hiding this, the fact that, well, first of all, it's not equal to 0. So that's the first thing I want to do. X to the 1/5 minus x to the 1/10 minus 2 equals 0. Now, which one of these is larger, a 1/5 or a 1/10? And it is written in the right order. 1/5 is much larger than 1/10. So the larger one's on the left. Question is this one double? So let's do the old W trick. If W equals the middle one here, x to the 1/10, what does W squared equal? Well, that means I'm going to take x to the 1/10, and I'm going to square that. Well, a power to a power, hey, x to the 1/10 squared, that's x. How do I multiply those fractions? That's x to the 2/10. That's x to the 1/5. Woohoo! This tells me then that I can use this as W squared minus W minus 2 equals 0. This one's a bit easier to solve because this is factorable, okay? This is W minus 2 times W plus 1 equaling 0. So that means either W equals 2 or W equals negative 1. But remember, that's not x. So this is x to the, what did we let W stand for? X to the 1/10. That equals 2, or x to the 1/10 equals negative 1. And you might be saying, well, okay, well, how, this one can't equal negative 1 because it's a, no, it can. It can. Because something, this is to the 1/10 equals that. That means, how do I solve this? Both sides? I raise both sides to the 10th power. Okay? So this one would be x equals 2 to the 10th power. Use your calculators, consult those. You can put that one out there in long form if you want. And then negative 1 to the 10th power, oh, that's positive 1. X equals 1. Now, as usual, go back and check these. 1 minus 1, does that equal 2? The 1/5 of 1 minus the 1/5, wait a second. 1 minus 1, does that equal 2? I don't think it does. How about 2 to the 10th? Raised to the 1/5. So that will be 2 to the 10th to the 1, or excuse me, 2 to the 10th to the 1/5. So that's going to be 2 to the 10 over 5, 2 squared, minus, and let's go 2 to the 10th to the 1/10. Okay, that's going to be 2. Does that equal 2? And that answer is yes. And this answer is 1 to the 1/5. The 5th root of 1 is 1. The 5th root of 1 is, the 10th root of 1 is 1. 1 minus 1, does that equal 2? No. Guess what that was? Extraneous. Okay? I hope those examples help. Good luck on your day 4 work. Okay? Make sure tonight you turn in your day 3. Have a good one.